Student distribution among colleges. A four-year university has 7 colleges. The school states the percentage of students in each college. A stats major student took a random sample of 700 students and asked them the college they belong to. At 1% alpha, is there enough evidence to show that the observed frequency fit the expected frequency? So 7 colleges. In column 1, we have science, engineering, business, social science, humanities and arts, education and graduate study, and then the expected percentage. This is what the college announced. So like somewhere in the bulletin or in the school website, they will say in our school, 20% of the students, they are in College of Science, and then 25% of the students, they are in College of Engineering, so on and so forth. And then you take a random sample of 700 students. The question is which college you belong to, and then you collect 150 science, 165 engineering, 160 business, so on and so forth. So this is the observed frequency. You run an experiment, you ask people one question, what college do you belong to, and then you collect answers. So this is the observed frequency, means the data that you collected. And then the expected frequency is based on what they announced. So all you have to do is to take n times p. So for the first college of science, you will be taking 700 and then times 20%, and then the next one is 700 times 25%, and then 700. So these are all 700s. You are taking the sample size, multiply the corresponding percentages. So 0.23, and then 0.06, 0.07, and then 0.09, and then 0.10, and then equal. Okay, so this is 140, 175, 161, 42, 49, 63, and 70. So this is the expected frequency. So expected frequency is not the data you collect. You do a calculation. So expected frequency come from calculation, and observed frequency is from data collection. And then for the null and alternative hypothesis, let's switch to a different color. So for H0 and HA, the way I picture chi-square goodness of fit is trying a new pair of shoes. So you go to a sneaker store, you are trying to buy a new pair of sneakers. What do? You try the shoes first, right, to see if your foot fits or not fit. So the null hypothesis will be fit, and then the alternative hypothesis is not fit. Right? So you put the shoes on to see if that is a fit or not fit. And then to elaborate a little bit more, so the null hypothesis, you should say this, the observed number of students in each college. Let's write this down. So the H0 is the observed, let's just write OBS, number of students in each college fit the expected number, EXP, number of students in each college. So for H0, then that is a fit. And then for HA, so for HA, all you have to do is you change the fit to not fit. You write everything else, so everything else stays the same, just change the fit to not fit. All right, and then the next step, you have to proceed to the test statistics. So what is the formula to calculate the chi-square goodness of fit test statistics? What's the formula? The formula is you have a chi-square symbol. So this is a chi-square symbol. So that is equals to the summation of observed minus expected square divided by expected. And then you do this for every single college. So for science, you have observed is 150, expected is 140. You square, you divide it by 140. And then for engineering, you have 165 minus 175 square divided by 175. And then for business, you have 160 minus 161 and then square divided by 175, and then you keep going until you reach to graduate study, which is 73 minus 70 minus 70 and then square divided by 70. So what is that approximately equals to? So that one you will have to use your calculator. I don't recommend you to do this by hand, right? I recommend you to use the function built in your TI graphing calculator. So the first step that you will have to go is look at the screenshot. Take out your calculator, so you have to hit the stat key. The stat key is right next to the left arrow. So you need to go to stat and then you go to edit. After you hit the stat, the edit is right in front of you. So you hit edit and then edit. So you put the observation in L1, the expectation in L2, and then you go to stat. So you hit the stat key again. So this time you hit the right arrow to go to test, and then you go down until you reach to chi-square goodness of fit test, chi-square GOF test. And then the chi-square test, the one above, that is for test of independence. Okay, so GOF, pick the chi-square goodness of fit test. Once you click in, they will ask you where you put the observed and expected frequency. So observed is in L1, expected is in L2. We have 7 colleges, so the degree of freedom is 7 minus 1. This is extremely important because the curve of chi-square is affected by the degree of freedom. So if you watch the very first video, the one regarding the concept of chi-square, the curve of chi-square is determined, the shape is determined by the degree of freedom. So if you change the degree of freedom, that affects the shape affects the p-value. All right. And then the color, pick any color you like. So once you click calculate, they will bring you to the home menu. So the chi-square is 1.787. So 1.787. So you don't need to calculate these long expressions by hand. And then the p-value is pretty large. So p-value, that is approximately equals to 0.9382. That is certainly greater than 5%. So since p-value is greater than 5%, you say you fail to reject the null hypothesis, you are not able to prove the alternative hypothesis is true. So fail to reject, you have a fit. Sorry, fail to reject H naught, the H naught you have a fit. So that means the fit, the word fit, remain suspicious. Maybe they fit. Let's write this down. So since p-value is greater than 5% alpha, then you fail to reject H naught. So fail to reject H naught. So that means you cannot prove HA is true. HA is true. So that means you do not have evidence to prove. So we do not have evidence to prove that the observed number of students in each college do not fit, because this is about HA, right? Do not fit the expected number of students in each college. So this one, do you still remember that I just said that the word fit remains suspicious? Maybe that fits. So if you say the word fit, maybe that is true. Do you know why? So let's pick a pair. Let's pick the last one. Graduate study, observed is 73, expected is 70. So let's put it right here. This is the p-value. I will talk about that in a minute. So you are taking a 73, right? 73 minus 70. And then you square the result, you divide it by 70. So this one, you have a 3 squared divided by 70. So what if, just a what if, the observed is 1 and then the expected is 70. So which fraction is bigger? So this one is a negative 69 squared divided by 70, since the denominator is huge. And then so that means this will be much bigger. So this will be a big fraction. And then this will be a small fraction. Okay, and then what's how do you calculate the chi-square? The chi-square is you are adding a bunch of fractions, right? So the sum of small fractions must be a small chi-square. And then the sum of big fractions must be a big, let's erase this, must be a big chi-square. What's the difference between small chi-square and big chi-square? So here is the result. Take a look at the graph. So this graph, do you see the red region? The red region is the p-value. The p-value is so big because the chi-square is small. So this chi-square is around 1.78. That is so small. So the cut is on the left-hand side. And then since the chi-square goodness of fit is always right side, so you have a very large p-value on the right. If when the chi-square is so big, so when the chi-square is so big, here is what happened. When the chi-square is so big, you have a graph like this. When this is so big, so this starts at 0, right? If the chi-square is big, you will push the cut all the way to the right. So the chi-square will be over here. And then such that this p-value will be tiny. So if the p-value is tiny, then you reject, right? And then you reject H naught. So that means reject H naught means the fit, the width fit. So this one is rejected. This one is reject. So the width fit is reject. That means not fit, right? Take a look at the 170. Can you say that the 1 fits the 70? Of course not, right? So that's why this is a reject. And then take a look at this one. This is a fail to reject. That means the fit, maybe this is true. Can you say that the 73 fits the 70? Maybe that is a yes because they are so close. So that's the concept behind the small chi-square and big chi-square. Okay, back to the p-value. So to find the p-value, you already have the p-value, right? So how do you find that manually? So to find the p-value manually, you hit the second key and then you hit the VARS key. You select chi-square CDF. That is for cumulative density function, meaning finding the area under the curve. And then the lower limit, that is the chi-square. The upper limit, I use 1 times 10 to the 99. To type that, you type a 1 and then you type second comma. The comma key is right below the sign key, SIN, right below the sign key, and then you type a 99 and then degree of freedom 7 colleges minus 1, and then you paste. You have the full command on your home screen. Click enter to get the p-value. If you are using an older calculator, they will show you a chi-square CDF and then an open parenthesis. Don't panic, just type these 3 numbers in this order and then separate them by using a comma and then click enter, and then you will get the p-value as well. All right, so that is the end of this video. I'm hoping that answered a lot of questions for you. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will see you all in the next one. Signing out.